Today we're talking about isosceles triangles. So here, this word is actually Greek. It means iso, which means equal, celis, which means parts. So it's a triangle which has equal parts, and more specifically, it's got two equal parts, or two equal sides, if you like, and two equal angles. So what we say here is this. We say if you draw a little triangle which is isosceles, then the point at the top is called the apex. And then we have this side, which is called the base. Now, the other two sides are going to be equal, and the angles at the base are going to be equal as well. So for these sides which are equal, we usually put a little line going through them, and that indicates that they are equal. And we can do a similar thing for the angles. We can put a little indication there, put a line through or something to show those are equal. In any case, what do we know about this angle, about this triangle? We know that the base angles are equal, and we know that if you draw a line from the top, from the apex, joining that to the midpoint of the base, then that bisects the vertical angle and meets at the base at a right angle. So firstly, this word bisect. This word bisect, it means cuts in half, in two equal halves. So this means cut in half. So if I were to draw the height going straight down, boom, like they've done here, what happened here is these two parts are equal. So if I use a little red line here, this is equal, that is equal, and the angle we've got here is a right angle. That's what they've told us. Okay, so let's move on. What other properties do we need to know? Well, firstly, actually, we know that the angles at the base are equal. If they are equal, then it's isosceles, and it goes vice versa as well. The angle bisector of the apex, it bisects the base at right angles. So what does this mean? The angle bisector of the apex. So this means the line which cuts the angle in half. So which cuts the angle in half. So this is the bisector. So what does it mean? It means that these two little bits at the top, this one and this angle, they're equal. So this, when you draw this line which cuts this angle into equal halves, it goes straight down. And when it goes straight down, it forms the right angle with the base, like we saw previously, and it cuts the base as well into two equal halves. It's just very nice and smooth what it does. The perpendicular bisector of the base, it passes through the apex. So if I were to draw a vertical line which cuts the base in half, then it would just cut the angle at the top in half as well. So everything is like connected, if you like. But anyway, let's move on to an example on what is it that we are doing exactly today. So here they're trying to confuse you because they gave you this triangle a bit rotated. And basically that means you need to notice that this angle here, x, will be equal to this angle up here. So it will also be x. Why is that? Because the base here is the side which is not equal to any of the other sides. So the angles of the base are these angles right here, the angle B and the angle C. So what do we know here? We know that all the angles add up to 180. So if we do x plus 38, this should add up to 180 degrees. So how do we simplify this problem? Well, firstly, notice that x plus x is just 2x. So we've got 2x plus 38 is equal to 180. Brilliant. Let's move on to another couple of steps. We've got two steps to go. Here we want to subtract. We want to do minus 38 on both sides. So what does that give us? That gives us 2x is equal to. Now, what is 180 minus 38? Well, it should be 142. Last step. Here we want to get rid of the 2 to find x. So we want to divide both sides by 2. So if we do that, we get x is equal to 71 degrees. And we are done. Now, it says here, notice, giving brief reasons. So what reason would we give for the first step? That would be angles in a triangle. This is the boring bit. Sorry, guys. Angles in a triangle add up to 180 degrees. So we don't write essays in maths, but we do have to give some reasons here and there. What else did we use here? We used the fact that these two angles are equal. So what we have to say here as well, because we assume that angle is also x, we have to say angles at the base of, and you actually have to do this, guys, because if you don't do it, you don't get full marks, of an isosceles triangle are equal. So hold on a second, the ink is lagging there. Of an isosceles triangle are equal. So these are the two reasons we need to give in this question. Right, moving on to the next one. We've got this shape now, right here. Okay, so notice what they've done. And once again, they're trying to confuse us. Let's pay close attention to this. This side is equal to this side. So what is our base? Our base is the side which is not equal to the other one. So it's this blue side right here. Now we know the angles at the base are equal. So this angle here, 52, is going to be equal to the other angle. So the other one is going to be 52 as well. So the two angles at the base are equal. Now, how do we find this angle x? Let's remember that property, guys, which says if you have an exterior angle of a triangle, that's equal to the sum of the opposite angles inside the triangle. So what that means here is x is equal to 52 plus 52. So x is equal to 104 degrees. So which property did we use here? We used the fact that the exterior angle is equal to the sum of the two opposite interior angles. So we've seen this before, actually. We've mentioned this in previous lessons, but something to keep in mind, and I do know some will forget, and that's fine. There's certainly another way to do this. But I'd also like to mention here that these two, we have to give a reason for these. Why are these equal? Because we've got angles at the base of an isosceles triangle. We don't have to elaborate further here. Let's just say angles at the base of an isosceles triangle. Now, another way to do this, the same problem could be solved. Let's call this the first method, if you like, so first method. We could have done it slightly differently. So what we could have said is, well, second method, we know that all the angles in a triangle add up to 180. So what we could do is we could say, okay, let's call the other one angle R or something, PRQ, let's call it that. So what we could say is this, 52 plus 52 plus angle PRQ is equal to 180. So you could have done it this way, which means 104 plus the angle PRQ is equal to 180, which means the angle PRQ is going to be equal to 76 degrees. So if this angle in there, let's use a different color here, if this is 76, then what we could do is we could say, well, x minus the angle 70, or actually, let's put it this way, both of them add up to 180. So we know these two add up to 180. So we could say x plus 76, well, these add up to 180 degrees. So if they add up to 180 degrees, well, that means that x must be equal to 180 minus 76. So that would be 104 degrees. So you see, using both methods, either method, you get the same result. So you choose what you see, what you remember best. Please use that and apply it. But don't forget to give reasons for each of your steps. Okay, so that's the idea there. And basically, that's pretty much it when it comes to the introduction of the theory for today's session. I'll be right here, ready to help you with any questions you might have. Let me stop the recording here and upload my annotations.